So let's start with the hypercompression. The hypercompression stands for our innovative mixed raster content compression engine. This engine is producing spectacular results by automatically adjusting the trade-off between quality and compression rate to provide top quality PDF MRC documents at the lowest possible file size, basically. At the core of the technology is our industry-leading segmentation engine that divides input image or document content into separate layers of binary compressible text. You can see that on the graphics as the layer number 2. Background, which contains continuous tone and image features of the document. This is basically the original document with extracted or without the text layer. This is the number 3 on the graphics, and basically the foreground layer, which acts as a chromatic channel for the binary layer. So if the text needs to be changed, we will color it with this layer, and we can save a lot of size by this technique. Using the advanced image analysis, we are then determining the most efficient compression techniques for each layer. And finally, we are composing these layers into the output PDF document using specific rendering instructions. This is a specific feature of PDF that allows this advantage over standard images, where basically you can only use one compression algorithm or technique over the whole image, while PDF allows you to use the composition, blending, and these kind of techniques to blend different kinds of images together and form one single page. The results of this effort basically are considerable document size reduction. We can reduce any 300 dpi color document page to a 20 to 60 kilobyte file, which leaves us with reduction in file size by about 90 to 95% in general, but we can get up to 98% in some cases. I will demonstrate this shortly. And we offer superior contrast and color saturation preservation and automatic document cleanup with no perceptible data removal or alteration, leading to improved OCR process recognition speed and rate if necessary. In some cases, the engine is also capable of improving the final quality of some lower quality documents by sharpening and similar techniques, again, improving the next phase of the document life. I have prepared some quick demos for you. So I will show you how easy it is to set up the hypercompression using our toolkit and see the results of the process with some comparisons. So I am quickly opening now the Visual Studio. I have prepared a very simple project here. Basically, just standard Windows Forms application. We have added the GD picture assembly that you can just download and put it straight in. And with just few small lines of code, so you can just register a product, and with just 3 lines of product, you can 3 lines of code, you can start processing the document. I would like to notice here that this is basically just one of the possible uses or how to use our mixed raster content compression technology, because it can be used on various parts of the toolkit, like by adding page to the PDF or in some of our end user products. So yeah, the GD picture reducer class is basically just one of those uses, which is very simple. So as you can see, we are utilizing these lines of code to process 3 documents from our input, which we have prepared 3 documents here. I will quickly run the process, just licensing information, and we are running the MRC demo. You can see in output, we will start seeing the process documents popping up, and we will be finished very soon. Boom, we are ready. And now we can start comparing the documents. So as you can see, the first document is very rich on text and images. Is a very funny composition. If you would be compressing this document, as you can see, the fidelity is pretty good on the document. If you would be compressing it with standard techniques, you would be probably getting something like this. So you would get this is the result of JPEG simple JPEG compression. You will get artifacts around text. The images will be very blocky, and you will basically lose possible information in some details of the document. You can compare it with our results. You can see that the document is mostly staying the same. If you zoom in, the text is still very sharp. Documents are not blocky. They are a little bit blurry, but they're still very usable. And if you will look at the details on the document, you will see that we have recognized the detailed text on some graphics, and we have preserved the information to make sure that we will get top quality document. The interesting part comes when you compare the size of the original document, which is 1.6 megabytes, and the resulting document is right now 68 kilobytes. So that itself is about, I believe, 95% compression. So very nice results. As you could see, the quality has stayed very high. We have another document which is classic scanned form document, and this one features, for example, barcodes. Again, the document in originals is roughly 2.8 megabytes, and if we check the output document, again, quality is very good. The barcodes are processed and optimized to be readable by machine reading technologies, and again, we have compressed the documents to 98 kilobytes. The most extreme case I can show you is this document that basically is 25 megabytes as original. The resulting document is just 60 kilobytes, so we can achieve pretty high compression rates with this technology while retaining very high quality of the documents.